Welcome everyone to Legumes in Space Live, the ExoLab-10 Ground Trials edition. I'm Lori Waters, Vice President of Learning Experiences for Magnitude.io, and we have a wonderful team here with us this evening as we are kicking off our ground trials as we prepare for our next mission called Carbon Farmer. So let's first start by hearing from our CEO, Ted Tagami, who's traveling this evening, so he left us with a video message.
Hello, I'm Ted Tagami, CEO and co-founder of Magnitude.io, and I want to personally welcome you to ExoLab-10 Carbon Farmer. This is our 10th mission to the International Space Station, and I couldn't be more excited about what we're doing as we've connected schools, science centers, museums, and libraries around the world. We even now have universities joining us in our research investigation. What are we doing this time? Oh my goodness, it's actually quite simple but profound in the opportunity. How might we grow the largest plant? We've got 4 weeks to do that. Whether you're a new user on our free platform or they're already using the ExoLab, what can you do to grow the largest plant? The most important thing as a scientist is you're going to want to document what you've done. These ground trials, these protocols that you're establishing right now are going to help us determine optimally what we can do when we send our mission to space this October. And so it's really, really important that you join us and you share your information. If you would like to get an ExoLab, pre-order it now. We want to make sure we have one for you for the mission. We've got more than 500 ExoLabs out there. We're really excited to having more of you join us as we connect the planet with these investigations. So there are a couple different objectives we have here. The most inspiring for me is, well, how might we put a garden on Mars? Right? That's actually a challenge that's the brightest and smartest minds on the planet really still haven't figured out. This is our chance, whether you're in primary school, whether you're a high school student, you're a university student, you're right there in middle school, you're a teacher, you've got gray hair like me, it doesn't matter, K to gray. The most important thing is we're excited about this opportunity. What might we do? Here's the fascinating part that I'm really excited about, beyond that inspirational putting a garden on Mars. How can we make life better here on Earth? The United Nations has something called the Sustainable Development Goals. And these goals are looking at the year 2030 or even all the way out to mid-century 2050. And we have some desperate things we need to consider, some urgent things we need to look at, whether it's our atmosphere, whether it's our quality of water, whether it's our living soil itself. The fact of the matter is we're depleting the nutrients in our soil through our current agricultural methodologies. As we imagine what it might take to boot up life on another world, it's probably a good idea to look at what we've got right here and how can we make that sustainable. Current modern production does a wonderful way, it does incredible science to increase production, but it's coming at a cost, and we're going to need to examine what we can do to mitigate those costs, the depletion of the nutrients in our soil, the excessive nitrogen or phosphorus that we have in there due to our current farming methodologies. Perhaps you, wherever you might be in the world, can help us figure that out. What is ExoLab? If this is the first time you're seeing it, our team here will describe it in a little better detail, but it's essentially a container that looks like this, with a sister experiment about 3 times larger that goes to space. And that's what we're going to be sending up in October. The ExoLab itself is measuring carbon dioxide, temperature and relative humidity, has a nice little light sensor here that measures the LED array that you can adjust, the photo period, the color of the lights, the intensity, and also we have a camera here that captures an image once an hour. Again, for the ground trials, you don't need an ExoLab. But if you've got one, fire it up and definitely use it because we do want to quantify the data that you have. You'll learn more about the ExoLab mission, ExoLab-10 Carbon Farmer, in the rest of this 30-minute session. My apologies for not being able to join you personally. I'm on a plane to Houston, but I definitely look forward to seeing you all online on our website during these live sessions over the next 4 weeks, and hopefully be able to see you in space as well come this October. Thanks for joining us, and I'm looking forward to this next mission in space. Hello, I'm Ted Tagami, CEO and co-founder.
So over the next 4 weeks, you're going to have an opportunity to be part of our ground trials. We'll be holding these live sessions here in the United States on Wednesday evenings. If you miss this live session and maybe you're on another continent, our friends in Australia are going to be picking up a second airing and leading the charge down under. So on the ExoLab page on the platform within the dashboard, we've added an announcement section. So you'll notice that new feature, and it's going to have your Zoom links and the schedule for when you can join into the live events. We'll also be recording these sessions each week. So if you want to show any segment to your class or to rewatch any. So what is Carbon Farmer? If you were part of our ExoLab-8 and 9 missions, you know that we grew red clover on the International Space Station. We were aiming to achieve root nodulation with rhizobia bacteria for the first time. And so it was an experiment really driven by the nitrogen cycle. Well, we do love our biogeochemical cycles, and so we're building on that knowledge from red clover and rhizobia, and we're going to fly another type of legume for ExoLab-10, and that's alfalfa. And so our student experiment will be using alfalfa in 2 of the test tubes. Yet we're going to add another experiment within our cube lab. And as Ted mentioned, that we're going to get a little bit bigger this time. We were in a 4U lab during ExoLab 8 and 9, and this time we're expanding to a 6U, so the equivalent of 3 of the ExoLabs. And that is because we're going to be joined by researchers from the Lawrence Berkeley Lab and Joint Genomic Institute in exploring barrel clover or Medicago truncatula, which is a model legume. And so this evening, in a little bit, we're going to hear from one of the lead researchers, Dr. Ben Cole, who's going to be studying this particular organism, and he's going to share with us some of his ideas of what he wants to investigate, what he's curious about when it comes to this particular legume. So our goal in this mission as Carbon Farmer is to try to grow the largest alfalfa plant. What does it take? What conditions are ideal for growing this plant in an artificial enclosed environment? So we're looking at not only trying to improve life on Earth of how to collect the most carbon, but ultimately think about too of in space, in a spacecraft, of how we can use the power of plants to scrub carbon dioxide from the atmosphere. That would be bioregenerative life support systems, and the technology is just not there yet. We need some more research, and so you can help with that research today. And as we develop it over the next couple of decades, you're going to see more of those commercial stations and more of those spacecraft using plants as a type of biosphere, almost like here on Earth, to take that CO2 out of the atmosphere. We got to do some of the ground trials first to get us started. We need to know what's the ideal temperature, what are the ideal light conditions, what about that growing media, different soils around the world, what are the special characteristics or nutrients of those soils in which the plant would grow even better. So these are some of the questions that you're going to help us answer. It's going to be an exciting 4 weeks here as we explore some of these topics together. And then on into the next couple of months, there'll be sessions digging deeper into some of the content areas and topics of how we apply it to the greater challenges on Earth, such as with climate change, and how you can be a solutionary in your own backyard and community. So at this time, I'd like to show also on our platform, we have a new feature with students and teachers as part of these ground trials. We are now going to enable you for the next couple of months to create a free account. And you can sign in as a learner or a teacher. And through the free account, you'll be able to see the lessons on the platform, the free lessons. And then, so you'll get some of the content. And then you're going to be able to see an experiment as well. We'll have our ground station hooked up, and then there'll be a new global experiment that you'll be able to view. This is so you can get a sense of what being part of an ExoLab mission is about. If you are already one of our users, you're going to sign into the platform and you're going to see some new features. So we have our welcome here, and now within our classroom library for ExoLab, we have a new set of mission lessons, all for all ages, K all the way through high school. And some of those high school lessons, yeah, I think adults would be challenged with them too. And we have a few of our curriculum developers here with us tonight. I just want to briefly introduce them. And we're going to be hearing from each one of them over the next couple of weeks, some of the highlights of what you can expect to see in some of these lessons. And so actually I'm going to stop sharing, and I'm going to call on each of them just to say hello and kind of talk about which lessons they created for just a minute or so. Let's start with our elementary lessons. You'll be familiar if you're back again with us is Javier, who's a teacher in Texas.
Hello, my name is Javier Montiel. Here I'm in Texas. Nice weather right now, waiting for Ted and Liam. So I'm specialized in K and K to 4 lessons. So I developed the full curriculum for this age band. I saw that whenever Magnitude was developing these lessons, they didn't have, or actually we didn't have lessons for early elementary. So my challenge is how to compel that knowledge and build a scaffold so the students can achieve better chances to get that knowledge that is coming from space. So that's a great opportunity for me. And we are also going to be implementing some lessons that are related to virtual reality. So stay tuned for the next sessions.
Wonderful. We look forward to that. That's going to be a fun project as part of this mission to have the VR capability and all that you've got demonstrated to do that. Steve Jones is back to talk about our middle school lessons.
Hey, so I'm Steve Jones. I'm a middle school STEM teacher, and my job is to kind of look at some of the curriculum that a lot of our high school teachers are doing, try to meld that with what middle school is doing on middle level. Actually practice the lessons with my students to try to figure out exactly how they're going to work for you all before you get lessons I've got is one of the free ones that's there is all about the history of rocketry and what is rocket science. So go check that one out. But look forward to getting some feedback from everybody on lessons.
Great, thanks, Steve. And we have Sabrina.
Hi, I'm Sabrina Ewald. I'm also a teacher in Texas, and I had so much fun developing the high school side, and I teach AP Environmental Science and already had a chance to try some of the things I developed. And my part was to focus on the beginning where kids get into the carbon cycle and really start reviewing those processes and then getting into the carbon farmer challenge of everything. And I hope that the high school teachers have a great time and find it challenging enough for their students as they're able to use the ExoLab experience with teaching these different subject matters that go with your curriculum, while just inspiring them to think about environmental here on Earth, especially with AP Environmental Science, and then making that connection to space.
Great, thanks, Sabrina. Those are some fun lessons too, new additions. So we've appreciated you being now part of our curriculum team. And we also have Art.
Hi, I'm Art. I wrote the bioregenerative life support lessons. So if you look through the lesson library, those are the fun math, chemistry, stoichiometry, dimensional analysis ones. I had a blast writing them. It was an intellectual challenge, to say the least. So I hope that your students struggle with it in a good way, right? The sort of struggle that begets understanding and strength and growth. I too have started test running a couple of the lessons that the rest of the curriculum team wrote, and I can confirm the kids are having a great time. And I hope to talk to you more in future sessions.
Wonderful. Thanks, Art. And we'll hear from Katie, who was also one of our developers in a later session. So as you're going to be getting started with your ground trial experiments, it's open. You can decide how you want to do this. As Ted mentioned, you don't need an ExoLab to get started. Now, if you do have an ExoLab, you can get it all set up and connected. Starting tomorrow, we will have the ground station unit connected called ExoLab-10 ground trials, and that's what you will pair to. It's your choice as to what growing media you want to use, what light color, the photo period, the photo intensity. All of those are decisions that you want to make with your students in getting it set up. But we want to hear from you and get some feedback and some of your observations throughout the experiment and at the end too. Our goal is to grow the largest plant. And so how are you going to do that? And then think about what data you're going to collect throughout the mission and at the end. And Art even and Sabrina work together in creating a lesson in measuring biomass, for instance. Or the younger kids might even just get out a ruler. Isn't that amazing, of putting that ruler back into the hands of the young ones, a little tool that they can really learn how to use after being out of a classroom because of COVID for so long. Some of them are even trying to figure out inches versus centimeters, right? And so getting them to make measurements again. If you don't have an ExoLab, you can set up your experiment in a recycled water bottle, a mason jar. It's your choice. You can also, if you ordered the ground trial kits, or if you want to order just the little plastic vials like this to set it up. This is one I did today with agar and rhizobia. I did one with soil, did one with vermiculite. So we're all going to test a variety of methods to see which one will work best. And then there'll be a Google form at the very end where you can report your data and your observations, your conclusions, and your recommendations. And you know what? I know some people who say, well, I kill every plant that I try to grow. Let me tell you a little secret in this one. All plants are going to die in the end as we probably measure them, especially if you're going to do the measuring of the biomass, because you have to dry them out. The young ones who maybe could retake their plants and take them outside and plant them in a garden, but it's okay because we learn from what doesn't work as well. That is just as valuable information. If you're, you set your plants in a window and it gets really hot and you're like, wow, I'm frying my plants. It's, 31 degrees C. Let us know that. That's whoa, we don't want to get to that high temperature. We want to see what is the ideal range for the plants to grow in, and then as best we can mimic those types of conditions. So how are we going to grow our plants on the International Space Station? Let me show back from our ExoLab-9 mission. Let's see if I can move this out of the way. I'll show just a little bit of the video from the installation of ExoLab-9. This is when astronaut Shane Kimbrough installed the Cube Lab. I'll go back just a little bit so you can see this is the Destiny module of the International Space Station. Oh, that astronaut kind of looks familiar. If you know who that is in the red shirt in the foreground, he's been in the news a bit. Maybe type that into the chat. But Shane Kimbrough was in the background here in the blue, and you can see he's in the Destiny module. This is where the Space Tango Locker is. And our experiments are pretty much autonomous. We assemble these cube labs and they get installed. He's handling that red card. It's a little hard to see. And then that's what gets installed inside of that Space Tango Locker. And so it connects into the power source and it runs pretty much autonomously. They do grow plants on the International Space Station in other ways too, such as through the veggie or the advanced plant habitat. If you followed the Space Chili Pepper Challenge last year and watched them grow the chili peppers in the APH and then enjoy space tacos, that was also a great plant experiment. But this is the astronaut time that we get, is when he plugs it in and then when he takes it out of the locker. So this is what it looks like on the space station and how we operate in space. And then when we get to being able to monitor on orbit, our inside of the Cube Lab will look like this. And we'll play just a few seconds. This was from ExoLab-9. And so we'll have a similar setup and be able to view our 6 test tubes while it's in orbit. And so here, even learning the lessons from this flight experiment, we had a little bit of media rotation. So how can we address that in a future setup? Maybe you have an idea. We're not going to use the biostraight felt this time because we're going to have cold stow going up and on return. And so that's also going to, I think, help our little roots get embedded to the media a little bit better. But what are the other ways that we could delay germination? Maybe you have some ideas that you can experiment with during your setup of the ground trials. So it's a wide open range of how you want to work through the ground trials over the next 28 days. What are the main things that you need to get started? Well, you need alfalfa seeds. That's what our organism is going to be, that we're going to focus on for our community science and educators and for students. And then you can decide if you're going to use rhizobia bacteria, if you're going to use soil, if you're going to use a different growing media, if you're going to use agar or not. How are you going to water your plants? So walk through all those steps with your kids and work through the lessons on the platform to help them understand the background of the carbon cycle and plant physiology. What really makes that difference in a plant growing small with little leaves or taller with a little bit larger leaves? At this point, I'd like to turn over to we have some of our researchers and friends from the Lawrence Berkeley Lab and JGI. Just want to give them an opportunity to say hello to us. And maybe I see David Gilbert is here, and we have Dr. Cole, and I believe Jean-Marie Volon's on too. So David, do you want to give just a quick hello from the lab?
I appreciate the opportunity. David Gilbert with the DOE Joint Genome Institute, a national user facility at Lawrence Berkeley National Lab. And I'm going to turn it over to my scientific colleagues because they're the ones who are doing all the cool stuff. So Jean-Marie, do you want to go first, or Ben?
I can just briefly say hi. I did not really prepare anything, but yeah, I'm Jean-Marie Volon. I'm scientist at the Joint Genome Institute, and I do mostly microscopy techniques to image plant bacteria interactions. So I was involved in the last mission with Magnitude. We got those very exciting samples from the space station, and we prepared them for some cutting-edge imaging technologies to visualize the 3D architecture of the roots and the bacteria that were hopefully around the roots. And we'll be doing the same kind of work on the next batch of samples from ExoLab-10. So yeah, very excited to be part of this initiative.
Wonderful. Thank you. We appreciate it. You did some great work, and we just phenomenal images back from those samples from ExoLab-9, even though we did find the little hitchhikers. So, but thank you for helping us find them. All right. And Dr. Cole.
Yeah, so thank you so much for inviting me to participate. I'm Ben Cole. I'm a research scientist at JGI. And really excited to be part of this mission. We mostly focus on aspects of how plants interact with their environment, including with their resident microbes, as well as some of the physical conditions that they're grown in. And one of the things that we're really interested in is looking at not just how the plant grows and, the architecture of the plant as it's being exposed to all of these different conditions, but also what all of the, all of the molecules within the plant, how they're responding and reacting to these various conditions. So we're really excited to try to look at the RNA expression of metacargo and alfalfa in space. So hopefully we find some really cool stuff. I'm just really thrilled to be a part of this.
Wonderful. And what is special about this particular legume that you're interested in? What is the difference really of why should we use that one rather than the alfalfa?
Yeah, so metacargo is a model species for legumes, mainly because it is a small, compact plant that's easy to grow, that has really well-documented associations with nodulating bacteria. And it's also, the genome of Metacargo truncatula is really compact. So other alfalfa species have really large genome sequences that have been, in some cases duplicated, which makes, analyzing the function of all of the genes within those genomes really challenging. So it's really nice to work with a model plant so that things are a little bit simpler to look at.
Great. If anyone has any questions, by the way, you can go ahead. We just have a couple minutes left and you can type those into the chat. If you have anything you need to know as you're getting started or any questions for our researchers or our curriculum team are here, you still have a couple minutes to type those in. Dr. Cole, just another question in terms of, thinking way down the line with post-flight science, what are some of the things that you think could be different, or have you even started thinking about that question yet, about what a difference it would make in growing in a test tube, small environment of a cube lab in space versus the one here on ground? What are some of the things you might expect to be different?
Yeah, I mean, it's really unclear at the moment. I mean, root growth and all the facets that influence how roots grow is strongly influenced by gravity. I have no idea how it's going to react when that's taken away. I mean, we hope that the roots, at least make contact, with the media and are growing in the media. And that the rhizobium are able to induce the formation of root nodules that are productive. What looks different about that versus how it behaves on Earth in gravity? I mean, it's it's kind of an open question at the moment. Yeah, I don't really have any good ideas as to what we might expect, but I'm sure a lot of things are going to be really different.
And what I find fascinating is that the technology now, we have the ability to, with these plants, to examine the genes, right? That you're going to be looking at the upregulation and downregulation, where genes get, essentially turned on or off or amplified in different ways by changing the environment. And so that's going to help deepen our understanding of space. And as Ted mentioned, ultimately traveling to Mars in a long duration mission and being able to grow off world, particularly with plants like legumes, that we need that symbiotic relationship with the rhizobia bacteria, that if that symbiosis can't occur because of the stress of spaceflight, then that's concerning if we try to grow off world. So we really appreciate you being here. And I think, let's see, you have a bird, and we have a couple of people who want to know what kind of bird you have.
I'm sorry, they're very chatty right now, but I have a Myers parrot and a Senegal parrot, and the two of them are unfortunately mortal enemies, so they're being, kept apart for the moment. But they're just saying hello.
Wonderful. We love that. So yes, as we are all still experiencing living, working, and learning from different environments, yes, if you have the kids that come in or pets that come in, we're happy to learn about all these different organisms. So thank you. We appreciate you being here and really leading this research.
Thanks for having me.
Thanks. Well, we are hitting up on our 30 minutes. So this is your final chance to get any questions into the chat. Each week over the next month, we will be meeting with different researchers and different experts in different areas that will talk about soils, regenerative agriculture, bioregenerative life support systems, how lighting affects plants. And from our different curriculum developers, as we look at how can students dig into this topic as here in the United States, there's wrapping up their school year, but in other parts of the world, this is kind of towards the beginning of their school year. So it may be a year-long project for them. We're excited to have all of you aboard with us and being part of these ground trials, and what you do will influence what we do in developing our protocols for flight in October. So we've got that date marked on our calendars, ready for mid-October, going up on SpaceX 26 cargo resupply mission to the ISS. So get your alfalfa seeds, get onto the Magnitude platform, either through your existing account or through your free account, and sign up and grow along with us. And we are ready to go. So we look forward to seeing you again next Wednesday, and stay curious, everyone. Have a great night.